Hello. To try and get used to this way of writing out the binomial expansion, let me now write out the formula for the binomial expansion again, with the understanding that we are actually doing it by picking out a number of x's from all the brackets. Let me write out a formula, the formula for the binomial expansion, and from there write out the first few terms again using that formula, so we can get used to using the binomial expansion. So the formula, which I've written out 2 videos ago, is 1 plus x to the power of n is equal to 1. Remember that n is a whole number. 1 plus nx plus n minus 1 over 2 plus wait, there's an x squared here, okay, plus n minus 1 n minus 2 over 3 factorial times x cubed plus dot dot dot. Okay, and the if I think about this as the term in 1 with no x, that's the term in x to the power 1, term in x squared, term in x cubed, and so on, then the term in x to the power of r, okay, the term in x to the power of r would look something like that. It would go n minus 1 dot dot dot, so that there will be more and more brackets as you can see. Now, but one thing that you notice is this: you see n minus 1 here when the power of x is 2. When x is power 3, it is n minus 2. So this last number here is always 1 unit less than the 3. Okay, so therefore we would expect that if you have to write out all these factors, the last one would be n minus a number that is 1 unit less than r. So it would be, I should put in brackets, r minus 1. Okay, so we have to write this out all the way until this term. And at the bottom, okay, at the bottom you see I have a 3 factorial here when the power of x is 3. I have a 2 is actually the same as 2 factorial when the power of x is 2. So the pattern is quite simple here in this for the bottom number. So if the power of x is r, then at the bottom we have r factorial plus dot dot dot. So this is what the general term, the formula for the r term, or the general term, looks like. And quite often we have to use the first few terms. So it's good to be familiar as well with what the first 2, maybe 3 terms look like. And just in case you're not familiar with factorial, let me write out what this means again. If I say 2 factorial, it means 2 times 1. If I say 3 factorial, I should mention that the exclamation mark here means is described by this word factorial. So 2 with an exclamation mark, we would call it 2 factorial, and it is equal to 2 times 1. And 3 factorial means 3 times 2 times 1. Okay, so you get the idea. Now 1 factorial is just 1. Okay, as 0 factorial would seem quite meaningless, seeing that if you have 2, you have to multiply until 1, and if you have 3, you have to multiply all the way until 1. So if it's 0, what does it mean? Okay. It doesn't have it doesn't exactly have a pattern that follows from this. So but it is defined as 1. So this is just defined. When we say defined, it means that we just let it be 1 for convenience. Okay, we might possibly be able to think about some clever reason why 0 factorial should be 1, but I shall not go into that. Right, so coming back to this formula, hopefully after going through all this and all this, and looking at the kind of patterns that repeats from term to term, hopefully we'll start to get more and more familiar with this idea, okay, and this formula itself. So let me now go back to the example that I wrote out just now, and see how we can use this formula. 1 plus x to the power of 10. Okay, so if I want to use this formula, usually in problems we might have to write out the first few terms. Right? That's usually what a problem would ask, to write out the first 2 or maybe 3 terms and then do some calculations, or maybe not. So if I want to write out, say, the first 3 terms, okay, let's see what it looks like. First term is always 1, that's simple. The next term is nx, and in this case n is 10. Okay, n is the power and power is 10. So nx is 10x. Okay, and this one, okay, it's just a matter of substituting 10 into the n. So it looks like 10 times 10 minus 1, which is 9, over 2 factorial, which is 2 times 1, x squared. And if you remember, this is exactly what I've written down just now. Okay, let me write this out as well. Let me write out the next term as well. N is 10 times n minus 1 is 9, 10 minus 2 is 8, over 3 factorial is 3 times 2 times 1, x cubed, plus dot dot dot. And let me just finish up by simplifying these two terms. 1 plus 10x plus. So, okay, factorials, we can evaluate it fairly easily for when the numbers are not too many. So I can divide 10 by 2 to get a 5, and 5 times 9 is 45 x squared. And okay, in this case I'll have, say, 9 divided by 3 is 3, and 8 divided by 2 is 4. 3 times 4 is 12. 12 times 10 is 120 x cubed. Okay,